Very good morning. So today's topic is, first of all, introduction to machine learning techniques. And whenever we are done with understanding all the machine learning techniques and machine learning, what it is, the fundamentals of machine learning, generally we apply these techniques in Python programming using a library called scikit-learn library. Okay, so today's lecture, we will basically understand what are the machine learning techniques, what are the fundamentals of machine learning, and then we will see using this library, using Python syntax, how can we implement these techniques on our own data set. Okay, so let us start with machine learning first, and we need to understand the fundamentals of machine learning first thing. So the first motivation of machine learning under artificial intelligence, okay, it came around 1959 or earlier, we can say. So first time in the year 1951, one very famous computer scientist called arthur samuel so he defined machine learning that it is the ability of computers to learn from data. Okay, so the computers we were training to learn from data than being explicitly programmed. Explicitly programmed. Okay, so we were trying to make that time computer researchers around 1959 or so, or earlier, always earlier to that, they tried to make machines or simulate machines in such a way so that the machines can learn from data set instead of explicitly being programmed. So is this definition clear to you, or we can understand it better? So what happens, suppose uh, I have earlier we were having some x and y values, and there are z values. Okay, and let me understand that this z value is ultimately a function of x and y. Okay, so whatever x and y input we have, our z is dependent on the values of x and y. Okay, so suppose if I values like 1 or 2, 1 and 3, 2 and 3, 3 and 4. And the examples, the z values are suppose 3, 4, 5 and 7. So just by looking at it, because the data number of data points is very small, and the relationship among x and y, the relationship that in which z is dependent on values of x and y, it is very simple. So we can say that z is a value of x plus y, or some relation like this. X plus y determines what will be the value of z. Okay, so when we try to explicitly program it, because I mentioned in the definition that it is the explicit programming, but in case of machine learning it is not programming. So when we try to explicitly program it, what do? We assume that, let us suppose we have a variable x, which is an integer type of variable. So it can take any value, integer numbers. Okay, and then we are also having another variable that is also integer type of variable. We are defining another variable, which is the z variable. And finally, we define a relationship between x, z, x and y, relationship between x, y and z, and we print the value of z. Okay, not this, we are printing the value of z. Okay, so every time we use some method where we define some method called sum x and y. Okay, that means this method will give us what? This method will give us the value of this. Okay, z, which is the x and x plus y. This is called explicit programming. This is how we explicitly program. Now, once we have defined a method like this, which can do the summation between two variables, What we need to do next time whenever we are having some computation, suppose if it's 3 plus 4, we know how much it is. Suppose it is a very huge number in 6 digits plus a very huge number in 6 digits, 7 digits. We cannot do the sum correctly. Okay. That time we use this kind of programming constructs. Okay. So that we can get the value. Okay. So this is all about explicit programming. Now, what is the difficulty in this kind of programming? So that we need to come up with machine learning. Okay. Now, what happens if we have this kind of construct and the relationship of my x and y gets changed for the same values? Suppose it is 1 2 1 3 2 and 3 and 3 and 4, and this time the relationship is multiplication. So it is 2 into 1, 3 into 2, 3 into 2 6, and 4 into 3 12, something like this. So just notice, for a similar structure of data, similar definition of data, just because my z value has different, my relationship between x and y has changed, I need to write a different programming construct for computation of this and a different programming construct for this, right? So plus and summation are just one or two simple computation methods that we can think of. But when we look at the real world, there is a huge amount of data, very, very big number of data, and very complex relationship among the data. There is complex relationship among the data. That time, instead of feeding the relationship into the data, what we do, we feed the data into the machine. Okay. So in case of machine learning, what we do is we have a well-defined data set. Okay. We run a machine learning model through the data set. Okay. And this particular machine learning modeling, not the model, if we run some sort of machine learning classifier, regressor, or anything within this data set, we will get a function of the relationship. We'll get a relationship where my dependent variables are based on my independent variables. And this kind of function ultimately I am getting. Okay. And more often we don't exactly know what is the function. That is why also a machine learning model is sometimes called a black box modeling. Okay. So we now if you look at this particular kind of data set, what will happen? Just by looking at the data, if I supply, there are 4 data points. Okay. Here, if you notice, 1, 2, 3, and 4. Here are 4 data points. Okay. If similarly I apply 1000 data points, I provide 1000 data points to determine the summation relationship between the independent variables. Okay. So this way, if I supply 1000 data points, my model has learned that the z value is dependent on x and y based on summation equation. Okay. Similarly, if everything remains same, I just change the data set. Suppose I name this data set 1. I change the data set. This time I am giving data set 2. And my machine has learned the relationship of multiplication, right? So next time when I provide new input values to this model, to this learned model, it can predict what will be the output of z based on the values of x and y. So whenever this kind of data set dependent learning happens to the system, we call this machine learning, which is not similar to explicit programming of the system. Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
If there is any question, you may ask. Okay. If not, then first let us understand that the first successful application of machine learning, okay, so it came around 1990s. okay, when we had something called a spam filter fixed to our email inboxes. Okay, so what happened? Every email that is coming to you, okay, email 1, email 2, like that, okay, if whatever email is coming to you, they are classified either as a spam or a ham. Okay, so this was the first successful application of machine learning that came around 1990s. Okay, so after all these things happened, another successful thing came around 2006 by one scientist called Geoffrey Hinton, and what they did is they classified some handwritten digits classified handwritten digits. This is a very successful and very talked about application. In next lectures, when you will be having ANN, CNN, okay, this data set, I think it will be definitely discussed. So what happened is, in this particular case, handwritten digits are, I write one like this, somebody writes one like this, someone may write one like this, somebody will write two like this, somebody will write two like this, someone may be like this. Okay, so this kind of handwritten digits from 0 to 9, okay, from 0 to 9, they have been classified into their classes, different classes. So this was another application of machine learning. This time they used deep learning. Okay. And from then on, from 2006 and on, when they could classify handwritten digits by supplying lots of digits and some algorithms, they have understood or once again realized the importance of machine learning in case of solving any real world problem. I won't say any, but quite a few real world problems that can be solved using machine learning. Okay. And at the same time, the boom of data also came. Okay. Because now when at the same time, social media came into picture. Okay. There came internet, then came this kind of concepts like big data, IoT, and all of these are ultimately what? Data generating mechanisms. They can generate a lot of new data. So in any sector, when there is a lot of data and you don't know what to do with the data, machine learning could be one first step at least to get some insight of the data. Okay. So this is all about the first fundamental concepts of machine learning. Okay. From my side. And now we need to know the different kind of data sets that are there in case of machine learning. So whenever we talk about machine learning, there are two kinds of data set that you must have heard. That is, one is training data set. Okay. Another one is testing data set. Okay. So we need to have this fundamental concepts of this kind of notations clear to us. So training data set is nothing but the examples that you are providing to the machine learning model to learn, that you want your machine to learn from this kind of data. That is the example data set. Generally, we call this entire data set as the training data set. Now, once you have the model, suppose your model has looked at this examples. How many examples? Let us suppose you have provided 1000 number of examples and you have fed this example to some machine learning model. Now your model has come up with one model and I'm telling you it is a black box thing. So I don't know. Suppose my model has given me this particular box. Let me call it model. Okay. It has given me some output in the form of function of independent variables. Whatever you have given, examples you have given, those function of those variables, something it has given. Now you have another testing data set. Generally, let me keep it around 200 examples. Okay, another 200 examples. Now what you do, you once again feed this 200 examples to this particular function you are feeding and you are getting the output. Okay. Now you have something called the actual output, which was a real output for this 200 examples. So whenever we are talking about examples, we know that this value represents this value represents this. So there is something called actual output. And if you feed these 200 examples to this particular function, your function is always predicting something. So you have some value called predicted value. Okay. Now the difference between the actual and the predicted value makes for the error component. Okay. So every time you are feeding this 200 data set to this particular function that your machine learning model has given as an output, and you are continuously looking at the error component and you improve upon this model. Okay, so ultimately there will be a point of a converging point where you can see that I cannot get a better model than this. Okay, that could be, suppose I have run 100 functions. Okay, and some function number 49. Okay, based on the independent value, function number 49 is giving me the minimum error. So I am not getting any better error component based on this particular 1000 examples. I fix this as my final model. So this particular model number is like my final model. Okay. So this is all about training dataset and testing dataset. So training dataset are those examples data points that are used to learn the model, and then the same model that we have learned, whenever we validate or verify the model, okay, that is with the testing dataset. We are testing the model basically with this component of dataset. Generally, if you have a dataset of 1000, 1000, 5000 examples, generally, as a rule, it is taken as the 80% and 20% data set. So 80% for training data set, 20% for testing data set. Okay. But suppose you have 1 million data set. Sometimes you are coming across a problem where you have 1 million data examples. That time, taking 20% of the data set just to validate the model would not justify your problem or would not fit into your problem. If you have a very huge data set, which is like around 1 million, 10 million, 1000 million data set, that time considering 1% of the data set as testing data set will definitely serve the purpose. Okay. Is there any question regarding training and testing data set or data sets for machine learning?
No, ma'am. Clear.
Okay. Okay. Now that we have looked at the simple machine learning data sets, we will see that the machine learning techniques, there is a 3 sort of classification of machine learning techniques. There are 3 kinds of machine learning techniques. Okay. So before going into machine learning techniques, all these techniques can be classified based on 3 categories. First of all is when this learning happens. I said that your machine learning models are learning from the data. When this learning is happening based on the amount of human intervention that is required or that is used, based on the amount of human intervention, machine learning techniques are categorized into 4 categories. Okay. One is a supervised classification algorithm. Another one is a semi-supervised learning. Another one is unsupervised. Another one is unsupervised learning. Another one is reinforcement learning. Reinforcement learning. This is one criteria of having the different kind of techniques. I will tell you another 2 criteria. Another one is how the learning is happening. Okay, how this learning is happening, whether it is happening statically, like once the machine has learned and there is no more new learning happening. Okay, or there is another kind of learning where on the fly learning is happening. Okay, so based on this, the machine learning techniques can be two types. Okay, one is batch learning or called the offline learning. Batch learning or offline learning. Another thing is called online learning. Online learning. So this is one another different type of machine learning technique. There is another machine learning technique classification of techniques based on how the models are uh, how the models are uh, treating the new examples. How models are treating new examples. Based on this, there are two more uh, classification. I mean, there are two more categories. One is your model-based learning, model-based learning, okay, model-based learning. Another one is instance-based learning. Okay, so these are three different criteria how you can classify all your machine learning techniques. Now, the major focus is generally into these four kind of learning techniques. Okay, so as we have little bit shortage of time also, so let us discuss about these four kinds of learning, and for the time being we can skip these things. Okay, model based learning, instance based learning, batch learning, offline learning, and online learning. Oh, okay, so first of all, as the name suggests, that is the supervised learning. Okay, so what happens in case of supervised learning? As the name suggests, so while the machine or the model is learning from the data, there is some sort of supervision. Supervision in terms of class levels or labels, data labels. How so? Suppose if I have a, if I am trying to break down a car, okay, different categories of car. So suppose it's like a Mercedes type of car, okay. Suppose it's a Toyota sort of a car. Suppose it's a Maruti sort of a car, okay. So these are my levels, data levels. And if I want to define the Mercedes class of cars, what could be the attributes or what could be the features that can distinguishly classify between a Mercedes car and a Toyota car and a Maruti car? The first thing, if I ask you, what could be the features? You may say the price. Okay, obviously it's a Mercedes car, the price will be higher. Toyota may be in the middle and Maruti will have the least amount of prices. Okay, so price could be a determining factor to classify between this kind of classes. Okay, then build quality could be one thing. Some of the cars will have very strong build quality and some of the cars will have little bit lesser build quality. Engine, the type of engine would make such differences. Okay, so whenever we have this kind of features and there are values, suppose if I talk about Mercedes, so the values I'm taking is a little bit irrational or something like that because it's an example data set. Okay, so suppose this value is around 10 million, this is value is 10k, this is 1k, something like that. Build quality is, let me take strong. Okay, it is medium. And in case of Maruti, suppose it is low. So whenever I have this kind of features, okay, but along with the features, to guide the features, I have this kind of levels also, data levels. So if the price is so, if the build quality is so, and the engine quality is so, this car could be of Mercedes class. So whenever we have this kind of leveling in the data, we classify it as supervised learning method. And this kind of attributes, they are generally called features in a machine learning algorithm. Features, okay. So when I talk about these particular features, this feature does mean the attribute plus the value. Okay, so the attribute could be price and the value of 10 million, 1000, 10,000, all these combinedly are called features. And these are called data labels. Is it clear?
Yes, ma'am.
So nobody else is responding. Uh, so this we spoken about uh, supervised type of learning. There is another type of learning. Before going to supervised, let me talk about unsupervised. What is unsupervised type of learning? Unsupervised. Unsupervised is I have set of features. Just excuse me for a second. Okay. So in case of unsupervised learning, what happens is we have features, but we don't have the label. Data labels are not given. That is, we have features, but we don't have labels. Okay, those are called as unsupervised type of learning. Okay, if I try to give you some examples, suppose I am having some rainfall data. Okay, some rainfall data of different districts. Different districts. So the set of features comprises of many features. It's a big set. Suppose, just for the purpose of explanation, I am talking about only one feature, which is amount of rainfall. Amount of rainfall. Suppose amount of rainfall is given in millimeter. Okay. So this way, I have a data set of 1000 data sets where I know that somebody has given me and I mean they have collected the data, rainfall data of different districts, and I have the amount of rainfall. Okay, so there are suppose somewhere it is like 1000, somewhere it is 525, it is 123, 243, some 20, 50, so many things. Okay, and you don't know, and obviously you want to classify them or you want to do something with the data. You if you have rainfall, different districts of rainfall data, now, one thing would be you can make like a cluster of cluster of districts, okay, which is like low rainfall districts having low rainfall or low precipitation, and something called medium rainfall, and something is called high rainfall. If you want to make these kind of clusters from this type of data, okay, but if you look at the entire data set and the data set is very long, if suppose it is having 1000 data points, obviously, can you say like if the data, I mean the class intervals are so, suppose if it is 0 to 50 millimeter of rainfall, I can call it, it's a low lying or low rainfall receiving district. If it is something around 50 to 100 millimeter, then it's a medium rainfall receiving district. If it is more than 100 to 1000, something like that, then it's a high rainfall um, receiving district, something like that. So if I statically bind the entire classification with this kind of rules, that means I'm doing what? I am explicitly defining some rules. Okay. But in case of machine learning, we always have the advantage when the model will automatically learn from the data. It will automatically tell you that there are equivalently uh, divided 5 clusters. Okay, 5 clusters that can best justify your entire data set. okay, where you are having this kind of different clusters. Okay, these are 5 clusters where this one cluster may be having some 200 values. This one is having 200 values. This one might have something lesser than 200, some 180 value. This one may have 220 values, something like that. But this would be the best defined cluster based on this data set. Now this time you don't have the supervision of labeling. You cannot determine then based on this particular label, you predict the new class. So whenever your new example will come, next time when your new example will come and your model has already given this particular cluster based on this particular data set and new example is coming, what your model will do, they will try to use this new example and find out the difference between the uh, difference, or we can say the similarity or the distance between this particular new example and the models, and it will try to predict this new example fits which of the clusters. Suppose this new example fits this cluster the best based on whatever similarity measure either the system has defined or you have defined yourself. Okay, so that is how this clustering, which is one particular type of unsupervised learning, happens, okay, without the supervision of data label. Is it clear?
Yes, ma'am.
Okay.
Madam, that means the system itself will do clustering, or we have to define again here.
No. So there are times when there is a measure called K value. Okay, K value is basically you are telling the system that give me 4 clusters. Okay, uh,
Okay.
you will tell that suppose or the system will take it, initialize it based on its own requirement that first in the first run I have taken 2 clusters. K value is 2. Suppose it is 2. So in the first go, system has made 2 clusters, and it will keep on improving uh, these 2 clusters. That suppose your data points are lying here, here also. Then automatically the system will keep on improving the number of clusters. Okay, then it will give you this is another cluster, this is another cluster, this many clusters can be made. Suppose you still have data points here and here and here. So the system will once again calculate in the second iteration. Suppose this is the first iteration. In the second iteration, the system will once again learn that this is another group of cluster that can be formed. So in case of clustering, you don't need to provide that give me this many clusters. System will automatically give you how many clusters are the best representative of the data set that you have provided.
Okay.
Right?
Got it. Thank you.
Okay. So we have learned supervised, unsupervised. Obviously, when we have supervised and we have unsupervised, there is another thing called semi-supervised. Okay. In case of semi-supervised, generally a huge portion of the data is supervised. That means you have got the labeling, you have the data points. Huge portion of the data is supervised, and a little bit portion or maybe a significant amount of the data is unsupervised. And you have this entire data set uh, where you want to apply machine learning. That will come under semi-supervised learning. Okay. So when you collect data, it is not a very easy task to collect a lot of data. And it is not very fortunate also some of the times when you have all the data very well guided with some class labels. Most of the time you will get some data where data is not labeled. It depends on the problem, the particular problem you are taking. So after all these things happen, there is another thing called reinforcement learning. Okay. I'm giving you this notation so that anytime you read any research paper or anything, you should have the fundamentals clear. Then only you can advance upon on any concept. What is reinforcement learning? In case of reinforcement learning, there is a concept called agent. If I look at an agent, suppose you yourself is an agent. You are an agent. You perceive on the environment around you. You perceive your environment around you. Okay. And you act upon that environment. And if you have done some good act, you are rewarded by something. Some mechanism we will try to reward the agent. Okay. And the moment the agent receives some reward, it keeps on going in the same direction. And suppose the agent has perceived the environment, okay, and it has acted in some other direction. Act 2, it has done something else, and this time it is not a very pleasant situation and you are not rewarded, or the agent is not rewarded, rather it has given some negative feedback, let me call it, okay, some negative feedback. So the agent has learned that instead of going to this path, I should be going to this path. This is another kind of reinforcement learning. Generally, this concept applies to robotics. Whenever in robotics also there is application of machine learning, because a robot is a machine, it is learning, but what it is learning on? It is learning its surrounding environment. So when there are hands and robotic hand, and it will say it can pick up the teacup, the coffee cup. So it has, suppose once it has picked up the cup and the cup fell down, so the agent is not rewarded. Okay, agent has got some negative feedback. So next time whenever it picks up, it has learned that the cup should not be broken. I should not hold it in a manner so that it's broken. So that is also kind of machine learning. Okay, so this reinforcement learning generally happens in robotics, but all this comes under machine learning. Okay, so this is one supervised, unsupervised, semi-supervised, and reinforcement type of learning.
Excuse me, ma'am. I have a question. Can you tell us some real example, real life application of semi-supervised learning? Like you told that robotics is the example of reinforcement learning. Same way data visualization is for क्या कहते हैं first one.
Clustering you can take. Huh. I got your question. Then, okay. Let me tell you, so in case of supervised learning, there are problems of regression. There is problem of classification. Okay, classification. We will expand upon these terms. In case of unsupervised clustering, you may have heard about clustering. There are terms like clustering, and then there is recommender system. We will not go into details, okay? Recommender system. This kind of problems comes under unsupervised learning. And madam is asking semi-supervised learning. So I will tell you one example. There is another, suppose there are, in case of WhatsApp and all, whenever we are typing something, sometimes I am writing मैं, okay, and I am writing मैं. किसी के लिए ये मैं है, for some this is मैं. So this is what these are called Hindi words, but they are typed in English. Okay, they are typed in English. So sometime if you develop upon this kind of data set, you take a lot of such words, okay, so it will be a huge data set, okay, and the data set is not so well defined where you have one word, rather you may have one entire paragraph, okay. So one paragraph is having so many such words. Now I want to devise some machine learning algorithm which can identify which is a Hindi word and which is a English word, right? Now what I will do, I have to annotate the entire data set. Annotation means what? I have to assign class levels. I have to assign that this particular word is Hindi, this particular word is English. This is Hindi, this is English. Likewise, I will keep on doing it. And while you keep on doing it, you will see such examples, because when we type this kind of sentences, na, there will be some words which you also don't know whether it's the English word, whether it's the Hindi word. Sometimes it happens. Suppose, matlab, abhi, just right now I can't think of a word like this, but even if you like extend this class, after this classroom also, if you keep on thinking, there are words, people who are multilingual, there are
लाइक मैं मतलब को हम मी इन इंग्लिश और हिंदी में मैं.
this could be definitely a very nice example. Like me, it is an English word if you look at the vocabulary. But for some, suppose I am not very good in expressing myself in this kind of terms, me could be for somebody.
Yes,
This
ma'am.
could be Hindi.
Yes.
Okay, so when you develop upon this kind of data sets, in fact, I will say in my own family, we are a bunch of multilingual person. So there are times when I ask people, so this particular word, what it is called in your language, what it is called in my language. And there are terms we don't know. Like the same word, it is for Tamil also, for Bengali also, it is there, for English also, it is the same word. There are in real life. So when you try to annotate this thing, you will come across points like this, that these are ambiguation. I don't know how to annotate it. Okay, so once you develop this entire data set, you sit with an annotator. So there will be some examples. So suppose if you extract this kind of paragraph, suppose you have taken 1 million such paragraphs, and you just break down one word, and you have 1,000 million word ka ek data set, words ka data set. Among this 1,000 million, you can come across 1 million such words where you don't know what is the exact annotation or the data label. That time, how do you deal with that data? Okay, how do you deal with the data? That is the role of a data scientist.
Okay.
Okay, so I may say 1 million data among these 1,000 million words is creating some problem. I want to forget this data. मेरे को देखना ही नहीं है. I will remove the data. I will go ahead with 999 million words. I will develop my machine learning algorithm. That could be one approach. Another brilliant approach would be something else, but that is based on the discretion of the data scientist. But if I do it, if I leave this 1 million words, that is the real application of a system now, because you would need a system like that can actually identify, which even the human beings are confused, like what it is, Hindi or English. And whenever there are systems, we generally rely on the systems much more than we do on ourselves. Like we have also learned grammar, but till date, when we check our English grammar correction in a research paper, we try to use a software. So that is the dependency on a software. So that responsibility lies with the data scientist, how strong a software you are developing. So I think we are clear
Yes, ma'am.
with semi-supervised classification,
Thank
right?
you so much.
Okay.
One more request, ma'am, little bit.
Yes.
It would be better if you explain how learning will be done in static, on-fly, online learning, batch learning.
I can tell you that, but that will take up a lot of
Just
classes.
5 minutes to go through the concept of ML in deep, because for the time being I have learned only learning types, human intervention. I don't know static, batch, so I just request if.
Okay, so let us go into that. One thing is offline learning. Another thing is online learning. So, batch learning is something. Suppose I have a data set of 1 million data points. Okay, I have trained a model on this data set. I have trained a model, and I have a model right now. I have a model which is this, and I have deployed it into a software. Let me look at it as a machine learning model only. Now my new data point comes. One new data comes. Okay. And this model has now become static, right? because
Hmm.
what it has seen within this 1 million data set,
Hmm.
that only, and around those kind of examples only it can learn. It
Hmm.
cannot learn on the new data. Suppose
Okay.
I'll tell you that it is a mango leaf. This is a
Hmm.
mango leaf.
Hmm.
This
Hmm.
is some disease.
Hmm.
Suppose let me call it spot blotching or something like that.
Hmm.
Okay,
Hmm.
something like that. Spot blotching.
Hmm.
Now I have used 1 million such pictures so that my machine learning model can tell whether this round spot is spot blotching or no spot blotching,
Hmm.
something like that. Okay,
Oh,
something
yeah.
like that. So
Hmm.
it has learned this around a green background.
Hmm.
एक कुछ तो ग्रीन बैकग्राउंड के ऊपर अगर
हाँ.
ऐसा है तो उसने लर्न कर लिया कि ठीक है,
Yes,
ये तो
ma'am.
स्लॉट बैचिंग या तो है या तो नहीं है.
सही है. हाँ.
Suppose right now I gave the model one
Hmm.
bed sheet having green color
Background.
background,
Hmm.
and on top of that background I have some
Red.
red spots.
हाँ,
Those are
red.
patterns. Those are not spot blotching,
Hmm.
right?
Right, ma'am.
How my model will classify it? My model will say
Hmm.
that it is 60% spot blotching, because some of
Hmm.
the patterns won't match. It could be
हाँ.
texture, because deep learning
Hmm.
models are so
हाँ.
nicely fine tuned. It will learn the texture of the leaf also. So the texture of
Yes.
the leaf and the texture of the bedsheet won't match. But
Hmm.
still, because it is the color, it is the pattern, somewhat it is
Hmm.
something equal. Okay. So it will say maybe according to me it is 60% spot blotching and 40% it is
What?
not spot blotching. Okay, but this won't be true. But if I come here, the model that I have trained, okay,
Hmm.
if I want to retrain the model with
Hmm.
this new data set,
Hmm.
how will I have to do it? I have to stop my software, or the
Hmm.
software can run. Once again, I have to use this data set here, right? I have to use this data set along with the 1 million data set that I have previously used to learn another new model,
Hmm.
right? So the
Hmm.
training has happened offline,
Hmm.
because training has happened. Once it has happened, right?
Hmm.
Once it has happened, and that time you are bar you are using the already learned model. You are
Hmm.
not every time on the fly,
Understand.
you are not learning anything.
Hmm.
Okay, this is the example of offline learning or batch learning. Now I will explain to you what is online learning. So the examples vary, okay, because situations
हाँ,
vary.
हाँ. Yes,
Ha.
ma'am. Sure.
What happens in case of online learning? So suppose somebody is hugely into trading. I
Hmm.
wake up in the morning, 9 o'clock, I open some software and I start trading. I
Hmm.
am investing 100 rupees on some Kotak Mahindra stocks. I am investing some 200 rupees on some Paytm stocks, something like that. Stock market, okay? So
Hmm.
9 o'clock. Around 9:10, okay? Around 9:10, your this thing has changed. So Mahindra stocks were going up. Suppose it is going up, okay?
Hmm.
And
Hmm.
Paytm stocks were going uh, up, and you have bought these things. Okay, now
Hmm.
you can see actually low. Okay, because whenever the stock prices are low, you will try to acquire them, and you will
Hmm.
try to sell them when the stock prices are going up.
Hmm.
Okay, so
Hmm.
now after what happens up to 9:10? Okay, 9:10, you
Hmm.
can see that your Kotak Mahindra stocks are going up. Okay, from this lower,
Hmm.
it has taken another up.
Hmm.
Instead of buying 100 rupee stocks of Kotak Mahindra, what will you instantly do? You will change your decision, because now you want to sell them. Okay, previously you
Hmm.
were buying them and
Hmm.
now
Hmm.
you want to sell them.
Hmm.
Suppose you have a software. Let me visualize this software as a billboard. As
Oh.
a billboard, it is continuously suggesting you buy, sell. something like that. And it is learning online, it is learning. Every time
हाँ,
it is learning. The model is not static. It
हम्म,
is every time, because in case of stock market or this kind of data, if you look at their data,
हम्म,
on seconds they are generating one million, one trillion, okay, trillion
हम्म,
data they are generating seconds, in seconds. If you look at Instagram, they are
हम्म,
generating a huge volume of data every
हम्म,
second new picture is coming.
yes,
The
ma'am.
moment you click on a picture, your feed changes. The next second your feed changes. The moment you click on a sari, all the next recommendations will be saris. Okay,
हम्म,
so that is not static learning, that is online learning.
हम्म,
So always the machine is learning with the new data set.
हम्म.
Okay,
In
so
that case,
exactly, yes.
इन दिस केस हमें स्क्रैच में मॉडल को किसी ना किसी डेटा से ट्रेन करना होता है कि शुरू में ही हम उसे डिप्लॉय कर देते हैं ऑनलाइन लर्निंग के लिए कि पहले थोड़े स्टैटिक डेटा से उसे लर्न करवाएं
Huh.
ऐसा
Actually, I will tell you one thing. Like, I don't have first-hand experience of
हाँ
training online learning of machine learning data. We
हाँ
don't have
आई
first-hand
ऑल्सो
experience.
यस
What I
मैम
have
आई ऑल्सो
theoretically read is that you start with some data. Suppose it is
हाँ
1 million
यस
data,
मैम
and the next second, your 1 million plus some next 2 million
हाँ
data. Once
यस
it is
मैम
learned, and this learning happens so quickly that every time you are
हम्म
seeing a new pattern that your data can uh, uh, data
प्रिडिक्ट
can
द न्यू
predict.
सिचुएशन
Yes, yes, that happens. But obviously, we don't have first-hand experience, means there's a lot of lacking in knowing
हाँ
also, like exactly what is happening in case of online learning, right?
बस इसमें एक चीज और है जैसे ऑनलाइन में अब क्या है कि हम जितनी भी एप्स बनाते हैं सबको फोन पे यूज करते हैं तो उसके लिए
हाँ,
हमें अब बार बार मॉडल लर्न कर रहा है और डेटा बढ़ता जा रहा है
हाँ,
तो वो स्पीड का इशू क्योंकि देखो सिस्टम भी रैम लेगा अगर वो बार बार लर्न कर रहा है तो वो हमारे सिस्टम की मेमोरी को या तो सर्वर पे जाके ऑब्वियसली सर्वर पे डिप्लॉय है ऐप तो भी पर हम उसे एक्सेस कर रहे हैं तो वो लर्न करके आंसर दे रहा है तो मे बी हमारा जीपीयू स्ट्रांग है तो मेरे को
हाँ.
ऐसा मन में लगता है मैम
No, you
कि
are absolutely correct. Whenever you are having online training of this machine learning and all these models, obviously it is computation intensive.
हाँ हाँ हाँ
Without
हाँ
having strong secondary memory storage, then your GPU parallel
मैम
processing, you cannot achieve online learning
हाँ
टुकुर
हाँ
करके.
हाँ
Either otherwise you are having very small data set. Just for the sake of
हम्म
trying online learning, you may try, right? Because we are having
हम्म
some 10 data set, and next
हम्म
second I have changed my 10 data set to 100 data points.
yes
Next second I have changed from 100 to 200. If you are having smaller data set, that time you can test with the server just for the sake of testing it. But actually to
हम्म
implement it in real world situation, obviously it is computation intensive.
जैसे एक और है मैम जैसे हमने डेटा विजुअलाइजेशन का वही किया है मैंने भी कि हमने वीट क्रॉप की डिजीज को प्रिडिक्ट किया है बट अब मेरा जो मॉडल है वो स्टैटिक डेटा पे ही है वो ऑनलाइन लर्निंग पे नहीं शिफ्ट हुआ क्योंकि वो जो एक बार ट्रेंड हो गया अब नई कोई इमेज देते हैं उससे वो लर्न नहीं कर पाता तो मे बी हमें फिर वही ऑनलाइन लर्निंग पे ही मूव करना पड़ेगा है ना
Yeah, another thing, you whatever new images are coming, and you see that those are the new patterns. You
हम्म
add those images to your data set and once again train the data. Let it be offline, but at least you
हाँ
have this
मतलब
time
कुछ
taken
कुछ
care of
टाइम
new
बाद
data. Yeah,
हाँ हाँ हाँ
if it
ये
is coming in
हो
the
सकता
way
है
of your accuracy or something, that
ठीक है मैम
that is one thing you can do. So,
ठीक है
so this is one thing.
Madam, one minute. Actually, we have a huge data set of weather data and also disease progress. So, which type of learning model we have to apply?
Okay,
Whether it
so
is
if you can expand your data set, if you can like define your data set a little bit more, do you have a y value or a dependent variable? How we
yes,
understand it? You have a
yes,
dependent
yes,
variable.
yes. Dependent
You
variable,
have,
all weather factors.
yeah. And you have lots of independent variables, right? It could be 100, it could be 1000. You
Yes.
have this kind of data set, right?
Yes. Yes.
Now I was just coming to this point only.
Yeah.
So if you have X and Y defined relationship, the first thing you can do is either classification or it could be regression. Okay. So generally classification is if your class levels are somewhat categorical in nature. It could be 0, 1, 2. It could be named variable like names of state names. Andhra, it could be suppose 5 states. Andhra Pradesh, West Bengal, some Delhi, some Maharashtra, MP. And you want all your, so these are categorical in nature. No matter in which terms you represent them, there is some categorical in nature, this data levels. If you have this, then you go for classification. Classify the data. So whenever new set of x1, x2, x1000 is coming, tell me whether it belongs to this class, or this class. Otherwise, tell me whether it belongs to this class, this class, this class, or this class. So what the model will tell you, suppose if the model has this kind of class labeling, 5 levels are there, your model will tell you that I feel 80% your data belongs to Andhra Pradesh, 2% it belongs to West Bengal, 8% it belongs to Delhi, 1% it belongs to MP, and some 9% it belongs to MP. And if you sum this probability percentages, ultimately it will come to 1. Obviously, if you are making some inference from the probability, you will say the if the model is saying that the 80% chances are for this independent data set to belong to this class, that means this data probably may belong to Andhra Pradesh. That is how classification works. Then how regression works? Regression works when you have this y value in the range of minus infinity to plus infinity. Suppose if I have the several features for a car. Okay, the car gives me this many mileage. The car ka model is this. The car ka what else? Price, something like that. I don't know. Mileage. This is the mileage. This is the model. And then what could be the price of the car? Okay. Now the price of the car could be 90,000, 23, something like that. 100.2, it could be 82, it could be 85. When your y value is this kind in nature, that time you go for regression type of problem.
Okay.
So now what will happen? You have 1,000 mileages you have provided, 1,000 model names you have provided. टोयोटा है तो टोयोटा में इतना माइलेज है तो इतना कार का प्राइस है, वॉक्सवैगन है तो उसका इतना माइलेज है तो प्राइस इतना है, ऐसे करके आपने 1,000 ट्रेनिंग एग्जांपल्स दे दिया है. Now I am asking, now I don't know what is the software. Now I go to a shop, I will just ask them, can I have a Ford data set, Ford model of car, which is having some, how much? 80 kilometer per hour or maybe more, 180 kilometer per hour. If this is the mileage I'm expecting, what could be the price of that car? Can you tell me? The salesman will quickly run this model and he will say, okay, this will come around 10 lakhs. For example's sake, I'm saying it will come around 10 lakhs. So what he is basically doing, basically he's framing the entire problem into regression type of problem. So that is the difference between a classification and a regression type of problem.
So what I wanted to ask you whether it should be a supervised learning or it's like unsupervised learning. What kind of things we have to use it here?
Okay, so that's why I asked you in the beginning that
Actually, the data works with the regression model only because based on weather factors, the disease happens. So we sort out the which weather influence on the disease based on the regression model by manually.
so if
In
it
this
is
case,
a if you
if
have okay,
yeah, if my question is, if my data is very huge, so for example, we have a 12 months data, it may be a 12 set, but we have a daily data also, and also hourly data, and different period of stages of the graph, and also disease. Disease is another part. The dependent variables are all weather factors. Then how to use these learning methods?
Okay. So, sir, uh, if your first question is, if you have already learned, if you have already, you have made up your mind or you are thinking that it's a regression problem, that
Yes,
means you have y variable.
yes, yes,
That means you have a well-defined dependent variable. If you
yes,
know this, that means it is definitely a supervised type of problem. Okay. Up to this point, we don't have any doubt.
yes.
Only if you have identified y, which is dependent, that is supervised, and if your y is not categorical, it is ranging between minus infinity to plus infinity, any range, that means it's a regression type of problem. By this point, we are done. Now you are saying, I have daily data also, I have hourly data also, and what else, sir? Monthly, and what else you said?
And that is different places also. It's for one set. We have
Okay,
a throughout India also.
yeah. Now, what is the what around what is the y value, or what is y basically? What you are trying to uh, predict with all
This
this
is
data?
progress. This is progress.
Disease will progress or not?
Uh, that is least part, one particular disease.
Okay, whether what will be
Whether it
the
is depending on the particular weather factor or not, we want to know.
yeah. So you are saying what kind of learning I will
Yes, yes,
apply here. Okay.
yes, yes.
So it depends now that under this daily variable, how many set of variables you have. Under hourly, what variable you have, how you can model this data. In case of monthly, how much data variation you are having. Can you have a some average on this daily data and extrapolate it to or hourly data? Like, can you have any average on hourly data and extrapolate that hourly data to your around daily data? If you do that, then you can take this daily model in case of breaking down it into hourly model. Okay. Then accordingly, once you have daily data, you try to have some average value of the daily data and extrapolate that model to predict some monthly model. And then based on that monthly model, you make your disease progression.
Madam,
Whether this can
eh,
be done or not, that you have to see in your data.
Madam, simply I would say, so if I have 12 data of weather factor, I can calculate for disease progression, whether it is dependent or not. But we have millions of data. Hourly means it goes in millions. Okay,
Are
we are
you
not
saying
able to
your
calculate.
features
Yeah,
are
yeah.
in millions? Are you
Features are
saying
same. Which features are same? Like RH means RH only. That is, we have 12 data monthly and also daily. And if you go into deep, hourly also. Likewise, many variables are there. Temperature, maximum, minimum, then wind velocity. Huge number of data sets are available. But we are not able to compute. So, what type of learning method we have to use it here? That I want to know.
sir, I want to ask you why you are not able to compute. Is it not fitting any regression model?
No, no, regression model, because data set is huge, we are not able to handle it.
Okay. So, mm
Or otherwise, I will write to you, then send the data, then you suggest us.
yeah, I think that can be done.
Yeah,
You
because you are
can
not
see.
able to get.
Yeah.
Yes,
At this particular point, I just want to clarify to the participants, always be clear that how many number of features you have and how much data point you have. Okay. If I look at the training examples, then these values are data points. That means how many observations you have. That is the data point. I think in case of Sir ka data set, he is having millions of. data points, but
Yes.
features he is having 12 only.
Yeah, features are same. Features
Yeah,
fixed.
yeah. So his problem probably would be to handle this million portion. क्योंकि
Yes.
million data set cannot be handled in an Excel file or a CSV file.
Yes, yes, yes.
Yes. So once we have this million data set, then how can we fit some machine learning model? That is the
Yeah, that is my question. Yeah, exactly.
problem you are saying. Okay.
Yes,
Okay,
exactly.
we can deal it outside the class. I hope you can
Okay.
understand this.
Thank you.
Okay. Okay. So by this point, I'm totally lost that what we should be discussing. So classification and this thing we have seen. And in case of this classification only, for classification, we have this kind of algorithm like k nearest neighbor is there. There is decision tree. Okay, there is decision tree. There is random forest, and then there is neural networks. And based on those neural networks, you have ANN, CNN, RNN, LSTM, and so many more. These are classification techniques. Okay. In case of regression, you have linear regression, you have polynomial regression, you have multiple linear regression, and another kind of regression which is logistic regression. This logistic regression ultimately serves as a classification technique. Logistic regression serves as a classification technique. Okay. Then there is clustering, which is another technique, and this clustering comes under your um, unsupervised data set. For that, we have k-means clustering, we have k-medoid clustering, we have DB scan techniques. There is hierarchical cluster analysis. Okay, hierarchical cluster analysis, HCA. Okay, and when you have a lot of features. Okay, so in the last discussion, when we said that he had some 12 features. Okay, so 12 features is less, and number of features are less or not, that depends how many data points or observations you have. Okay, now the question is, suppose I am having some 1000 features. Okay, to classify or to regress or anything on a data set of 2000 data points. Okay, so here you can see the number of features are too high for this particular number of data points. Okay, when this happens, and if I try to make use of all these features to learn on this particular number of data sets, generally a problem of overfitting arises. Okay, we will go into overfitting little late. Before that, we can sometimes drop or eliminate some of the features that we feel or our model feel that it is not necessary to have those features. If I drop some 800 features from this, how do I do that? We have PCA for that cluster. Then we have some recursive elimination techniques. Okay, there are several different techniques where once again automatically the model will drop the unnecessary features. You don't need to uh, do that. I mean, you don't need to on yourself need to tell like drop exactly these features, because you don't know which feature is affecting which of your data point in which way. So model will automatically do that. For that, you have different mechanisms. Okay, so now we will come to what are the main challenges of machine learning. Okay, so the first thing is that whenever we try to apply machine learning, there is a lot of data dependency. We are dependent on a lot of good data. Okay. Then there is something called the unreasonable effectiveness of data. Okay. Unreasonable effectiveness of data. this is what happens. There have been, like, scientists have earlier, they have encountered problems where just by selecting a complex algorithm have not solved their purpose, rather than by selecting more number of data points, okay, more number of data points, they have solved complex problems. There is natural language disambiguation, problem of natural language disambiguation, somewhat similar to what I discussed with madam earlier. Okay, natural language disambiguation. So they have seen that the moment they are increasing the number of data sets, they have published a graph also. Okay, the moment they have increased the data set, suppose at this point they were using 1 million data, whatever was the accuracy, when they have used 100 million, they have used 1000 million, same algorithm, the algo remains same. Okay, so the same algorithm has performed much better with increased number of data sets. So the unreasonable effectiveness of data, that is literally a paper titled by Peter Norvig. He actually released this by calling that we till now we haven't understand what is actually happening inside the black box, because there is precedence of performance of data set over the choice of algorithms. Okay, if that makes sense. It came around 2009. That is one thing. Third thing is, when I talk about all this thing, there is what type of data. Now, when you were having 1 million data and you have increased it to 100 million data, just by hearing that more number of data will serve your purpose, but you have taken non-representative training data. Okay, non-representative training data. That means whatever data you have collected, that does not represent all your different cases. Suppose I am talking about natural language disambiguation, and I am only considering the ambiguation between Hindi and English. That definitely does not count all the natural languages. So obviously this model won't be cannot be generalized for all the languages generally speaking spoken in India, right? So the non-representation of training data. In this particular case, there are two terms. One is called the sampling noise, and another is one is called the sampling bias. Why I am telling you so? Because in later things you will understand. Whenever you have chosen a little data set, too small of a data set, too small, your data set is too small, and it does not, obviously it's a matter of chance. By chance, you don't have true representation of the population. That is called the sampling noise. But there are cases even for bigger data set, even though you have chosen a very big data set, still your data set does not have equal representation of both the classes. That is called the sampling bias. Okay, so this is one, these are the limitations of machine learning we are discussing. Then obviously comes the poor quality data. When I talk about poor quality data, there is concept of outliers, there is noise, there is errors. Okay, even human errors also happen, because if you are annotating a particular type of data using human annotators, that means there are chances of introducing errors. So poor quality data could be one thing. Another thing could be irrelevant features. You are using a lot of features which are irrelevant, which are not helping you in making the decision. So these are the, in like broader terms, you can think of these five limitations. So the next thing that once I discuss this, I will move into the practical later on. Okay, there are two terms called overfitting and underfitting. Because if you are doing machine learning, discussing machine learning with somebody, and you don't understand the concept of these things, it is difficult. Okay, overfitting, the most simple way to understand overfitting is when you have very low training error. That means your model has learned so well on the training data, but it has a high test error. Okay, that means whenever you are showing some new data points to the model, it is not able to generalize well, generalize very well. Okay, that is the concept of overfitting. So understand, suppose if I am classifying something into yes and no classes. Okay, one class is yes, another class is no. Okay, and I have used some 1000 training data set. Okay, now my model has learned so well on this 1000 training data set, it is giving me 98% training accuracy. Okay, the moment I introduce some new data in the testing data set, because my training data set has not seen any values within the testing data set, and my training data set is also not a having well representation of new data set. It cannot generalize well. And my testing data set, some similarly, it is giving some 20% accuracy. So the error percentage is very high in case of the testing data set. So you need to understand that your model has overfitted to this particular training data. What you need to do in this case, if your model has overfitted, you can do first of all two things. First thing, you increase the data point, not with garbage data, but with true representation of your yes no classification, that what data that actually matters to the model. Increase the data point. Other thing is you may reduce the features. Okay, because your features are so elaborate and so descriptive that uh, it has not learned very well. It has learned very well on the training data set, but not generalizing very well to any particular data set. Suppose if a yes no data set is something like this, it is some yes no data set is, and your learning curve is something like this. Okay, something like this. That is a overfitted model. Okay, rather in comparison to that, if your this particular model that I'm talking about, suppose it is having this kind of a slant, although it is misclassifying this one or two data set, but it can generalize well on a new data set. Okay, whatever data that falls, but this line of regression or the line of best fit, it must match to the pattern of the data. Okay, that how your data is distributed on this plane, that also you have to see. So this is one concept of underfitting. And if you talk about some, that was the concept of underfitting I meant. And if you talk about underfitting, that means your model is too simple to classify the data. Your model is too simple, okay, to learn the underlying structure of the model. That time what you do, you select a more powerful model, select a more powerful model. Now you may ask, how will I select a more powerful model? Because suppose one support vector machine model, it's a model, so every time it should be safe. No, if you change the hyperparameters of a model, you are changing hyper parameters of a model, sorry, parameters of a model. That means you are either simplifying the model or you are complicating the model. Okay, so that is basically the concept of overfitting and underfitting. Is it somewhat clear?
Yes, ma'am, it is clear. One more thing, ma'am, how to remove the outliers. Outliers भी हमारे डेटा में कई बार होते हैं जो हमारे रिजल्ट को प्रॉब्लम करते हैं. तो
Yes.
जैसे डीप लर्निंग मॉडल में हम लोग आउटलायर रिमूव करने के लिए, मतलब मॉडल खुद ही जैसे फीचर्स वो खुद ही एक्सट्रैक्ट कर लेता है, उसे पता लग जाता है कौन से सही है। ऐसे ही आउटलायर वो खुद रिमूव कर देता है, या हमें कोई फंक्शन होगा जिससे उसे रिमूव करना होता है, ये एक क्वेश्चन है मैम।
Okay, then if whenever you are representing your data, you can have first of all, if it's a like bivariate classification or something like this, sometimes you
मल्टी
can
क्लास क्लासिफिकेशन में भी
हाँ
yes,
sometimes like that. So before applying any sort of classification regression technique, if you make a visualization graph like that, and
हम्म,
you can see then there are outliers in the data. Okay,
हम्म,
either you can remove them and then have the classification
हाँ
would be
तो
doing,
ये
or
हाँ,
yes, or if you are aware that there are outliers in the data and then you are doing the classification and having some accuracy difference or something, then you can explain the results also accordingly.
ओके
Okay, so every time whenever you are applying machine learning, because it is little bit static in nature, that whatever is happening in the data, once you have fitted some machine learning model to the entire data, you always have to see the explainability of the result.
ठीक है मैम।
Okay, so
हाँ
if you are reporting high training error and low testing error or something like that, you are reporting low accuracy, that is not a problem, because every data set cannot be handled with highest amount of accuracy, and that should not be the case also. So you can have low accuracy. What you need to do is you just have to have the explainability that why your model is giving suppose 75% accuracy, because there are data sets, not everything is that thing na, that we can have like 80% accuracy. So the problem is not having 75% accuracy in your data set. The problem is not knowing that why did I have 75% accuracy even though I have did everything well. So fitting a machine learning model, along with that, if you can visualize your uh, results, the model and the explanations, that is the best representation or the best use of a machine learning model. So sometimes you must have seen in research papers, even though they have predicted and their predictions are here, and they have represented that my model trend is here and my actual data points are here. So why they are using the the help of visualizing data visualization techniques to explain the results more.
हाँ यस मैम। पर ये वाला केस में हम लोग जैसे ये वाली चीज एप्लीकेबल होती है जब हमारे पास टेबुलर फॉर्म में डेटा हो। अब जैसे जो पिक्चर है इमेजेस तो हमें टेबुलर फॉर्म में, मतलब ठीक है सिस्टम तो उन्हें डिजिटल फॉर्म में पढ़ता है, पर हम लोग तो उसे रिप्रेजेंट आई थिंक कर पाएंगे क्या विजुअली, मतलब विजुअली इन
कैसे
द
डेटा के लिए आप विजुअल की बात कर रहे हैं? इस टाइप ऑफ
जो
डेटा के लिए?
इमेजेस का मैम, इमेजेस का जैसे डिजीज की इमेजेस है,
हम्म
वीट क्रॉप की लीफ की इमेजेस हो गई, तो
हम्म
उस डेटा को तो हम भी उस ऐसे विजुलाइज आई थिंक नहीं कर पाएंगे। हम ये
ऐसे
कर
नहीं कर
सकते हैं
सकेंगे, हाँ।
हाँ, कि भाई हमने ये मॉडल लगाया, इस मॉडल की ये एक्यूरेसी, उसका एक आई थिंक बना सकते हैं कंपैरिजन, है ना।
So, in that case, I would want to ask you one question, that whenever you are having this kind of image data sets, how are you defining your outliers? Which one is the outlier for you?
हाँ यस मैम, उस केस में तो हाँ यही मेरा भी था कि उस केस में तो हम आउटलायर भी आई थिंक नहीं बता पाएंगे कि है भी कि नहीं है
हाँ,
ना,
for
क्योंकि
me,
दोनों
because I
फीचर्स।
told you, if you have classified all your diseases in mango leaf, I change the mango leaf, disease is same, causal organism is same, rice leaf if I give, will you count it as outlier or will you say कि this does not fit my model का assumption? Because
हाँ
assuming this model is for wheat,
हाँ
won't work for rice. So, but
हाँ,
will you consider this as an outlier?
नहीं
No. So I
नहीं
think for image data set
हाँ
in our division only, this AID team, they have worked na disease identification system for crops. So they have seen because the app has matured a little bit, I think over a year. So I think they can share some insight with you. So what kind of data they are considering as outliers, or what kind of new data they are coming, like which are outlier, only the change in background, changing disease pattern, texture. So they can give you a better
Yes.
insight into the image data set. So after I have told you one thing, just two things are I have to discuss. One is this is yes.
Ma'am, just want to know one thing. Like mostly na people ask that you should have a large data set to apply some modeling technique. Then only whatever accuracy you are getting is good enough. But what if we have low data and our model is accurate?
So you need to define what is the low
Number of
data point. So I'll tell you one thing. Suppose so for this also you want this whatever I'm telling now. So I will reply to madam first. First of all, you define the problem that is there. Okay. So what problem you are trying to define? Suppose I am trying to define, I'm trying to classify anything. Suppose something I'm trying to classify into two sets, whether they are yes or no. Just a binary classification. First of all, you go through the review literature. This I'm talking for research perspective. You go through the review literature, whether for the same kind of classification, anybody has defined any data set. Before telling this is big, this is less, let us know if there anything exists. Suppose there is a data set. So there could be two cases. Yes, somebody has defined this problem, classified this problem with 1,000 data sets. Okay. And there could be one thing, there is no data set. If there is no such data set and you can come up with at least 800 examples where 400 are positive and 400 are negative. Okay. Then with respect to your 800 data points, you have to keep your features low. Number of features should be low. So there is a thumb rule, generally a thumb rule that if this is the number of data points, how much should be the number of features? That you please Google. Right now I have forgotten the rule. So if there are 800 data points, you can define where you are having 400 positive classes and 400 negative classes, and you are getting some sort of accuracy. Let it be 60% accuracy. Okay. Can you explain this accuracy? If you can still report this result, is what I'm trying to mean. And suppose somebody has got 1,000 data points to classify this particular problem. Your first instinct would be to find out this data set and call it as a benchmarking data set. Okay. So this time, whatever model you are developing, suppose he has used linear regression. You are thinking, I will use support vector regression that he has not used. Or there is some new model today itself has come. I want to use that model. You first of all develop your own model. Try to compare your model based on the benchmarking data set. If you can report this, that also is acceptable. So before having the concept of lesser data or more data, first of all, you need to have some idea whether there is any data that can exist. If not, can I define the data? And can I publicly release that data? If you can, then also you can fit some machine learning model and it is acceptable for any research publication.
Okay, ma'am. Thank you, ma'am.
In case of image data, there are so many other techniques like data augmentation and GAN. These are also used for increase the volume of images because in real field we are not able to collect the data in one season, millions of images. So in that case, we are using data augmentation techniques or GAN technique, generator and transformer technique, which can increase the volume of data.
So what was the question, ma'am?
No, I am giving the answer to ma'am, asking now how you can increase the volume of data. If it is the data relates to images, it can increase by data augmentation technique or GAN technique. I just answering the question, ma'am. Nothing.
Okay. Yeah. If that is one thing, that is separate. If someone is saying that you are having very less data, I will suppose you are trying to classify a disease on paddy dataset. Okay, and you are trying to classify disease 1 and disease 2. Okay, her question is for disease 1, suppose I have 50 data set, and suppose for disease 2 I have, once again I have 50 data set. Okay, if I augment it in 4 direction and I make it some 200 data set, okay, into 4, in 4 directions you will augment it, no? Because you can, this also you augment it in 4 direction. I am having 200 data set. Okay,
Yes.
but
Yes.
for the same disease classification, somebody, some zoo et al has already publicly released a data set where they are having, for D1 they are having 800 images, for D2 they are having 800 images. Then any model developed on this 200 data set won't be acceptable if you don't compare the results of this with this.
Okay.
Okay, for that also you need to apply the pipeline of applying machine learning. This is also what I mean. GAN is not GAN exactly, but this augmentation technique is when you, it is just looking at your data from various perspectives, from various angles. If you look at an image from one angle, your model may not have understood the image very well. But if you look at it from every angle, from right side, left side, up and top and bottom, you might have a better perspective. That's it.
मैम
But yes,
अगर जैसे आपने एग्जांपल दिया कि जू एट ऑल का 800 वाला डेटा सेट का कोई मॉडल पहले से एग्जिस्ट कर रहा है तो 200 का एक्सेप्टेबल नहीं होगा, बट अगर किसी कमोडिटी के लिए कोई पहले का डेटा या मॉडल एग्जिस्ट ही नहीं करता है तो क्या 200 वाला एक्सेप्ट होगा?
हाँ होगा. That depends on the publisher. Because if your paper has the merit that you have, that's what I told you, that if you have explained 60% accuracy, but if you have explained it enough, you have justified your result, you have supported your results with enough graphs and charts that this is happening, you have taken care of every mishappening that is happening in the model, then obviously it will be acceptable based on publisher's discretion whether it should be published or not. If your problem has that importance, that this is what I'm trying to classify, and it is really important for the researchers to distinguish those kind of data. So the problem is relevant enough, obviously it should be acceptable, no?
Okay.
Yeah. So the last thing that I had to discuss, that what are the steps to implement a machine learning project. So first of all, you need to have a well-defined problem where you have defined the problem, whether it's a supervised, unsupervised class and all these things. After you have done the problem, you have to do data collection. Data collection includes a huge, makes up for a huge part of your machine learning projects. Data pre-processing. So once you have your data, you need to do the denoising, whatever outliers are there, you need to remove them, you need to tackle them. Okay, all these things. Suppose there is imbalance in your data. Your positive set is having 800 data set, your negative set is having 200 data set. That imbalance you have to take care. If you have to see if in by chance, if somehow you can increase the amount of the negative data and reduce the amount of the positive data, those kind of bias and all these things you have to take care. Once you are done with the data, you have to come for feature engineering. Feature engineering involves everything like extraction. First of all, you extract features from the data. You select the features. That means, suppose I am having 10 features, but for this particular problem, only 2 are relevant. So this kind of feature selection, that is important. So all those comes under feature engineering. Ho gaya. After you are done with the feature, you have to go for the model selection. Which models you want to try? Okay, whether if it's a classification thing, you cannot use your regression models. If it's a regression thing, you cannot use classification model. So accordingly, you have to select what are all the models I'm trying to develop. There is model training. You have to, whatever model you have selected, you have to train the model. Okay, then you have to evaluate the model. So generally, evaluation of the model happens with testing data set or with validation data set. Okay, these two kind of data sets are used for evaluating the model. Once you have trained the model, evaluate the model that how good it is on new data. Then there is model fine tuning. Okay, uh, there are something, even though you can see that suppose you have used a random forest, you have used support vector, you have used naive bayes, something like that, and you can see at any chance support vector is performing better than random forest and naive bayes. Now you want to see that there are 4 kernels for support vector machine, so which kernel is probably giving me better performance. Hyperparameter adjusting, if adjusting any of the hyperparameter is giving you better results or not, that you have to see. That basically comes under model fine tuning. And I'll give you 3 more steps. And after that, you will be having model testing. Obviously, once again, you will test the model on your independent data set, which is completely kept aside from your training and testing, all this kind of data set. This can come for benchmarking data set also. And then you deploy the model, okay? Deploy the model in the server for testing, whether it's working or not. And ultimately, when you have deployed it and you have a software or any front end, their development and maintenance you can call. This is all about how can you implement a machine learning project. Okay, so on an average, what you need to keep in mind is, first of all, the problem, then you deal with the data, then you deal with the feature, and then model. While you develop a model, you select the model, train the model on your example data set, evaluate, fine tune, test, and deploy. These are the steps. Okay, is it clear for all of you?
Yes, ma'am, clear. Fine tuning, ma'am, means checking the data with the actual or predicted.
No, fine tuning the model is like I told you that suppose you have taken 3, 4, 5 models. Okay, and you can see random forest is giving you 80% accuracy. Support vector is giving you some 90% accuracy. Naive Bayes is giving you 70% accuracy. So mota you have understood that support vector is working fine on the data or performing better. Now you want to know if changing the hyperparameters of support vector is helping your data or not. Okay, that is called fine tuning a model. Okay, so fine tuning also differs in case of different problem data set. Fine tuning has a different meaning in case of pre-trained model. Those are also there. So काफी कुछ है. So at this point, I will take a short break for I don't know whether changing that will change here also. So let us start. So this is a notebook that I have prepared to demonstrate scikit-learn. Okay. If I tell you about this library, you can see this particular API reference, okay, for scikit-learn. So this particular library you can use for all sorts of machine learning, whether it's clustering, classification, regression, and every kind of whatever methods, classes it has, whatever the things that are there, you can see in this particular page. Okay, this scikit-learn API documentation it is. You can see there are so many data sets that are defined here. So before going on and trying machine learning in your own data set, you can use this example data sets also. So many things are there. Okay. Just have to start recording. Okay, it's recording. So you can see here, apart from that, you can see this sklearn.datasets. This includes so many datasets. Okay, you can before using in your own dataset, you can use this kind of datasets and apply the algorithms and see so many feature extraction, selection, everything is there. Okay. Apart from that, let us start from here. So I hope in earlier classes you have seen the demonstration of pandas, numpy library, matplotlib library. Additionally, we have taken only one library we are using, that is the sklearn.datasets import load underscore iris, and this is the collab notebook you can see. So for collab notebook, you don't need to make any additional installments because all the libraries are given on the fly. It's on the cloud and you can just import and use it. But if you are having this project in your local system, then you have to install all the packages that you will be using. Otherwise, it will show you some import error. So first of all, I am downloading this iris dataset. If many of you must be well versed with the iris dataset, basically it is having 4 independent variables, okay, which are sepal length in centimeter. This is to morphologically describe a flower by the sepal length, width, petal length, and width. And looking at these 4 parameters, you can guess the name of the target, which is the species, whether it's setosa, versicolor, or virginica. So these 3 Y values are basically the Y value for this particular iris dataset. Okay, and this data.feature names, it will give you the X values. Suppose you load your own data set, that in that case you have to define what are the X values which will be doing X equal to, and you can select the column of your data set that must have been shown to you in the previous class, and the Y value also you need to define. But in this case, after importing load underscore iris, here you just use this method to convert it into a data type of variable. Okay, so it's like data and it has feature names and target names. These things only work for this iris dataset and the sklearn library. If you use your own dataset and then import it into a data frame library, that time feature names and target names won't be applicable. Okay, so these are the variables. By default, it is given in the load underscore iris method. Okay. So once we have this thing, that means we have our X values and the Y values. So I can print data.target. If you give data.target underscore names, it will give you the name. But in case of target, it will give you the changed, numeric correspondence for this species. So one thing I didn't explicitly specify in case of the theory of machine learning, that is, you can only apply machine learning in case of numerical data. So suppose you have any other kind of data, whether it is image data, you can say text data, audio, video, any kind of data, sequence data, you have to transfer those data into numeric values. So the output also, even if it's a categorical type of output, like 3 names are there, you have to change it into some numeric attributes. So setosa species has been changed as 0, coded, or they are encoded into 0, and versicolor is into 1, and virginica as 2. Okay, so these are I am printing as data.target. Now I will define, for easy references, I will define data.data equal to X. Okay, so I am giving all the independent data values to X, and if you print the shape of X, you can see it is 150 rows and 4 columns. Is it visible to all of you?
Yes, ma'am.
Okay. So this is X, and if you transfer this data.target to Y value, and if you print the shape of Y, it is 150 rows. It's a one-dimensional array only. Okay, 150 comma nothing means one-dimensional array. So it's like 150 Y values in 150 rows. Okay, so we will change this Y value to a reshape using a reshape function, where it will change it to a two-dimensional value where it is giving 150, 1. That means it's a 150 rows and 1 columns. Okay. So once I have this X and Y definition of the iris data set, you can plot this figure. Okay. And this kind of code is available everywhere in the internet. So for practice sake, you can copy it from anywhere and use it. You just have to be specific whether the libraries you have installed in your system or not, whether you are using any other variable name, then change the name of the variable. Time here and there, some errors may come. You can Google the error and always solve it. Okay. So if I use this particular matplotlib PLT function, then I have defined the size of the figure. Okay. And then I am plotting a scatter plot where my X level is the sepal length and Y level is the petal length. Okay. Then accordingly, we have defined this particular scatter plot that is given. Then based on the X values, what are the Y values? Okay. So after we have defined the X and Y value, the next thing we do is the train and test split. Okay. So from sklearn.model selection, you just have to split it into train and test section. Okay. So over here, we split the data into X and Y trainer and X and Y tester. Okay. So you have to keep these names in this fashion only. Otherwise, it's by default, it will return whenever you are calling this method, train test split method. Okay, whenever you are calling this method, by default, the first variable goes to X train and the second variable goes to X test and the third and fourth goes to Y train and Y test. So idea of X train and X test is clear to all of you, or do I need to mention? Is it okay for everybody?
Yes.
Hello? Okay.
Yes.
Will it be random classification every run at every run?
A random classification?
I mean,
Yes,
the
sir.
at every run, whether it will be a random classification.
It will be for X and Y, you are saying, na, training and
Yeah,
testing.
that's split.
Yeah, sir, the split will be random, but if we
Okay.
fix that,
That I understood. That percentage I understood.
yeah,
That
seed size, if we mention now, once I put a comma and then I keep space, you can see here something called random underscore state
okay,
is
okay,
there.
then fine. I got
Yeah.
it, got it. Thank you.
Yeah. So if it is the seed value for the other participants, I am telling you. So if you fix one random state value, then every iteration of this method, it will give you one static training and testing classification. Otherwise, if I keep the training testing split like this and I run it 2-3 times, so every time my train and test data will change, because this train test classification will be randomly defined. If you want to keep it same, you have to specify the random underscore state value to anything. That means you are specifying a random number to this. And here, if you focus, so two values I am passing. One is the X value, one is the Y value, X and Y. And test underscore size is 0.20. That means 20% of the entire data set will be given as test data. Okay. So after that, we have defined X train, X test, Y train, and Y test. Generally, in your own data set, when you do this X train, X test, Y and Y test, I advise you to print the shape of this kind of data sets, just to see what dimensional array you have generated from this after this splitting. Okay. So first thing we are talking about is logistic regression. Once you use logistic regression, and two more methods, as you can see here, from sklearn.linear model. So many model functionalities are possible. So if you provide linear model, from the linear model you have logistic regression. You can import logistic regression, and from sklearn.metrics you can import the accuracy score you want and the classification report you want. Either you can print the classification report, or if it is difficult for you to understand, you can print the confusion matrix also. It is given. So once you run the logistic regression model, so you can see that logistic regression, this is the constructor of this particular class called logistic regression, and there are so many values that are possible. Okay. So many things you can give. If you just hover over it, you can see that you can see from here also. If you go into model selection, then you can see so many models are given. Okay, so many models are given. You can use any one of it. Under model selection, there is train and test split also. You can use the k-fold classification. These are for cross validation, repeat k-fold. Okay, so many things are there. You can explore on your own. There is cross validation predict and cross validation score also. Okay, once you have done all these things, I wanted to show you the logistic regression. So for that, you just do sklearn logistic regression API documentation. So you have sklearn.linear-model.logistic regression. Once you open this, all the values are defined here. Specify the norm of the penalty. So these are all the attributes that the method can take. Okay, you can you can use any one of this. You can see the random state here. This is used for why it is used. Everything is given here. Okay, there are solver. So there are times when some error may come or something that you need to apply. That time you can use all this. You can see there is maximum iteration is given. By default, it is 100. So if you don't specify any value to this maximum iteration, automatically it will stop after 100 iterations. If you want, you can specify more than 100, like 1000 or something like that. And you can see other things are given here. Okay, all the attributes are given here. There is intercept, number of features, okay, feature names, iteration. So for any package, whether it's in Python, Java, you need to have the little bit, always you need to look at the API so that you can make use of all the attributes and methods that are there. If you want to simply run through, so this is the logistic regression. You define the method. Maximum iteration I have given 1000 because for 1000 it gives the best performance. Even if you use 100 iterations, it will give you some error that the model is not converging. It will converge at a better iteration number. Okay, so you fit this regression. So this is basically you are defining a variable where the variable has overridden all the methods that are there in this constructor. Okay, logistic regression. This is only the you are defining the model. But when you need to train the model on your data set, this is basically the training step, which is logistic_regression.fit method. And under this fit method, what do you provide? One is the x train value, one is the y train value. So this is x_train, and this y_train, I have given it as np.ravel order C to change the dimension. Instead of a 2D array, this one will take a 1D array. Okay, only one dimensional value for the y value. So this is the conversion of that 2D to 1D array, np.ravel. Okay, so once I am using logistic regression.fit method, that means I am training the model into the logistic regression method with the logistic regression classifier or regressor. Then I have to make predictions. So I'll use this particular model to predict, and we will predict on the test value, which is the x_test. Okay, so whatever I am making prediction, that is the y_pred. So all the results that I am generating or predicting using the test value, I will save it in y_prediction. Now when you want to print the accuracy score, it will be y test and y prediction. So you have the accuracy. You can print the classification report with, this is the classification report basically, y test and y prediction, and target names equal to data.target names, which is giving you all the species names. Okay, so this is one thing. And regarding this classification report also, I also understand this report a little less. That's why I always use the accuracy score and I use the confusion matrix. Okay, this is another thing that is required. So from sklearn.matrix, so by this point you must have noticed that this sklearn library, separately it is having some matrix package. Inside that you have classes like confusion matrix. There are others also. Let me show you what are the other classes that are there. So you just use sklearn matrix API, run this. Okay, sklearn matrix and scoring. Sometimes you want to specifically print something. That time you have to use this APIs. Otherwise, nobody can always know that exactly which one to use or what. You can see here. So under this matrix, if you want to print accuracy, you have to import accuracy score. Okay. If you want to print F1 micro, macro, all these things, you have to print. You have to import these classes matrix.f1 underscore, all these things, recall score, precision score. Okay, these things are there. You can print, use this ROC USC score, all these things. There is adjusted mutual information score also. So whatever is required, that you can use. These things, mean absolute error, mean square error, RMSE, these things are generally required. And one example, usage example also, it is given here. Okay, import the SVM datasets, cross validation score, everything is given. You just have to make use of whatever you need. So I have used here the confusion matrix, and using the confusion matrix, I am generating the y underscore test and y underscore prediction, confusion underscore matrix. And I have passed the same matrix here to generate the following SMS.heat map. If you don't want this, you can separately print this confusion matrix also. If it not changed here, you can just matrix. Because I have done these things also. So see, this kind of confusion matrix you can see. So this is basically 0, 1, 2 levels and 0, 1, 2 levels. So all the zeros that have been classified as 0 is now is in 11. And first species, that is called the first species, is 13. Okay, this is the decoding confusion matrix. So all of you have idea about confusion matrix, or should I just explain? Please tell me, okay, whatever you need more emphasis on. Okay, so these are the actual classes and these are the predicted levels. Okay, so these are the true levels, actual classes, and these are the predicted levels. Accordingly, we have specified. Okay, this is the confusion matrix you can see. So 11, 13 and 5, these are like truly correct specification. Only one is not correctly specified. The total number of thing was 150. So 20% data set only it has used for generating this confusion matrix, which is less. Then you come to the support vector machine model. So one is there, this logistic regression, which is used as the classification model, and you can print the probability of every class also. Okay, so this is support vector machine model. How can you do this? So from this sklearn library .svm, you import the support vector classifier, SVC classifier. Everything is available in API documentation, SVC classifier. So under SVM classifier, you are selecting the SVC classifier. There are other kernels also. As I was telling you, fine tune the model by changing the hyperparameters. So these are basically the hyperparameters. Sometimes in case of logistic regression, what are their maximum iteration and other values are there. In case of support vector classifier, there is different kernels are there and other values are there also. You can specify the cross validation, how many cross validations you want, whether it's 5 or 10, that also you can specify here. So accordingly you do it, and then once you have defined the SVM classifier, you use this classifier to fit your training, X training and Y training data, and then make the predictions based on Y underscore print. And you can see that SVM classifier dot prediction is X test. And then you generate the accuracy score and the classification report. For that, this accuracy and classification report method to print, accuracy score and all this to print, you just have to import these statements, sklearn.matrix, accuracy score and classification report. So as you can see, this sklearn library has separately this matrix class also, okay, which is giving you all the collection of all the evaluation matrices that are there. If you hover over these points, it will show you the entire values it can take and what is the meaning of those values. Everything is available. You need to understand these things and explore it on your own anyways. And then sklearn.linear model. So if you look at the linear models, you have logistic regression and other models. If you want to select any model, model selection, then for that you have train, test, split, and all the things. So this is the accuracy and the classification report in case of support vector machine model. And then you can use the random forest model. Now this random forest model, how does this work? In the next class, it will be dealt with ensemble technique classification. And in case of random forest classifiers also, you have all the, this is the entire list of hyperparameters that you can train, and you can have so many things with you. Okay, so number of estimators are 100. Here it is given. You can use some criteria. Gini index is there. Other methods are also there. Maximum depth and feature. So this you will understand once you understand the random forest classifier itself. So you can change any of the parameter now values and see whether it is affecting your data. Sometimes if I have used it on my data, then I have seen it does not make much difference. So I have left it like that. Maybe my data is not good enough for that matter. So, and here also they have used random state equal to 42. So they have, specified classified the number of trees it will make. So now how many times, however times you run this application, it will make the same tree. If you remove this random state, it will make different trees in every iteration. Once you have defined this random forest, you fit this method on your X train and Y train data. You make the predictions, and this is the accuracy classification report. These things you can generate. Okay, and based on this spread also, suppose if I make it ypred underscore rf, okay, and then I change this values. Okay, so this one now I can generate the confusion matrix for this thing also, random forest also. If I look at the random forest classifiers, instead of this I will pass ypred underscore rf. This thing can generate you can see, you can generate the heat map also for the same thing. So you can see two values have been misclassified. In case of logistic regression, it was one value that was misclassified. So for simple data, you don't need complex models. Simple models perform better on simple models. That also you need to see. So is there any question, or is the notebook visible at your end? Can you manipulate it? Can you work it on your own data? Participants, is there any question you want to?
No, ma'am.
Have you run it from your end?
Madam, for comparison of these models,
Hmm.
only accuracy has to be seen, or any other metrics we can use?
Okay, so for classification, if you are for classification, only
Yes.
accuracy is not enough. You need
Yeah.
to see, you need to print the precision, recall, you need to print the F1 score. Okay, then you need to print the MCC, Matthews correlation coefficient. You can refer to any research paper on machine learning they have used for binary classification or anything, that there they have used so many 5-6 different types of things which you can generate from the confusion matrix itself. Like the
Okay.
accuracy is having a formula that is generating from the confusion matrix. Okay, precision recall. So everything you can print from the confusion matrix itself once you look at the formula. Here also formulas are given.
Okay. Thank you.
Okay. There is MCC value, there is sensitivity, there is specificity, and it depends that what kind of operation you want to do for information retrieval. You would want precision recall, all these things. I am giving you another notebook. Can you edit this craft regression at your own computer? I have
Yes,
copy pasted the link in chat box. Okay.
yes.
So there is this one difference. Once you look at the IDs dataset, that was having 3 species names which are of categorical nature. That's why we have used classification there. Okay. In case of regression, we have imported some other dataset, which is the load underscore diabetes dataset. It is a diabetes dataset. And you can see from sklearn.dataset, we have imported load dataset. And we have bifurcated this dataset into X and Y variables. So all the database diabetes dot data. If you use this dot data and dot target, that is you are defining your X and Y variable. Okay, once again, I'm specifying when you use your own data from an Excel sheet, a CSV file, this dot data and dot target won't work if you have not defined it. These are basically attributes that are already defined in the load database method. Okay, this is specific to sklearn's load diabetes data. Sorry, load diabetes data. Okay, for data for this also for IDs dataset also. So you can print one diabetes.decr, which is the description about the diabetes dataset. So anytime, sometimes if in classes also, if we define regression problems, if I give assignments to 2 students, they will come and they have already applied this regression on a huge dataset, but they don't know the dataset. They don't know which variables are where, which variable means what. So whenever you are using any dataset, if it is not your own, then it is always advisable that you look at the description of the dataset. You can define the dataset description by describe method, info method, in case of data frame objects. Here you can use this diabetes.decr, which is description. So this diabetes dataset, it is having 10 baseline variables. It is telling one is age, sex, BMI, average blood pressure, 6 blood serum measurements are there were obtained for each of n equal to 442 diabetes patients. That time when we were using the IDs dataset was having 150 rows. Now in this case, this one is having 442 diabetes patients, okay, as well as the response of interest, a quantitative measure of disease progression 1 year after the baseline. They have they have seen that what will be the measure of disease progression. Okay, so understand 3 things, that the n value, which is the number of instances, how many examples you are passing, that is 442. Number of attributes, that means how many independent variables are there. There are first 10 columns which are numeric predictive values. These are also numeric predictive values. None of the values are having male, female, or any categorical in nature. If you have in your data set, if you are having values like male, female, then you have to change all your male values to 1, female to 0, or vice versa, anything. If you are having some others, small, medium, large, this kind of values, you have to change it to 0, 1, 2, this kind of encoding schemes. Then the target value, which is the Y value. So column 11. So first 10 columns are your independent data. Last 11th number column is your dependent data, which is 11th column. It is a quantitative measure of disease progression 1 year after the baseline. And this is the attribute information you can see here. So this entire is your feature set. Okay, and then this S6, it is the glucose level, blood sugar level. All these things are there. Each of these 10 feature variables have been mean centered, scaled by the standard deviation. Okay, these things are not needed. So this is all about the data set. Now, once you have defined the data set, what you have to do, you have to train and split the data, train test into train and test. So here also you can see you have specified X and Y value, and these are the by default arrangement of your value, train test. Okay, and testing size you have mentioned 0.2. You can keep it 0.31, anything based on your requirement. Random state, I have already mentioned, this is the seed value. So you specify it to one value every time you run the same thing, same data set, you are having the same train and test split. Okay, if you don't specify this value, you will be having every time you will be having different set of 80% and 20% data set. Okay, then you have from this scalar model, you have selected some linear model, which is the first is the linear regression. That was the logistic regression. This is the linear regression, LR equal to linear regression. So basically, linear regression will give you a model like y equal to mx plus b. If it's a multiple linear regression in this case, and if you are using all the 10 variables, then it will give you M10, M0, X0 plus M1, X1, M2, X2, likewise M9, X9 plus B, the intercept for the Y value. Okay. Now, once you fit the model on the training data and to try to predict the X test, so this is the fitting, linear regression, LR, and you are fitting this to X train and Y train. Okay. So, that is the fit function you are using for training the model. So now you have trained the model. Instead of writing iris model, you just write diabetes model, something like that. You can write anything. Okay, so you make the predictions based on diabetes model dot predict X test, and you print this method. Okay, once you have printed this, you have made the predictions. Now you want to look at the predictions and see how much error you have generated, because it's a regression method. Your see model evaluation matrices have changed. This time the evaluation matrices will be mean absolute error, mean square error, R2 score, all these things. And for that, you just have to specify the Y test, which is the actual value, and the predictions to every method. If you call each and every method, you have to import the classes first of all. Okay. So you run this method, you have these values. You can run it for some time, and for some more iterations, you can change the this thing, and you can have better accuracy, because better mean absolute error, mean square error, and this is having 10 independent variables. Also, you can get rid of some of the variables if you have understanding. Then another thing is, once I define this multiple linear regression with y equal to mx plus b, where m runs from 0 to 9, x also runs from 0 to 9, then all these 9 values of m, these are the coefficients. Okay, so the coefficients of this model I can run like this. So you run the coefficients, and the b value, mx plus b, this is the b value, which is called the intercept. If you know regression, you know that what is coefficient, what is intercept. Yeah, basically, coefficients are the constant part attached to the x value, and intercept is the b value. That's it. So, so you have the coefficient intercept, and you have the R square value. So you know 45% R square is very less. So the model has scope for improvement. And then scalar dot SVM. From there, you can call support vector regression. That time we did import support vector classifier SVC, and this time we are taking SVR. And here also we have option of 4 kernels RBF, and there is polynomial linear RBF, and one more kernel is also there. So 4 kernels are there for linear to non-linear transformation. Okay, for this I need separate SVM classes. So this is the support vector regression classifier constructor I'm calling inside the regressor underscore SVR variable. Now you use this to call the fit method. You use the fit method x underscore train and y underscore train, and once you do this, that means you are training, and then you make the predictions using predict method. Once you have predicted, then you print absolute score, square error, R to R square, like this. Similarly, you can use the random forest regressor, and to run the random forest regressor, you can specify it to number of estimators equal to 100, then fit it to X train, Y train model, and you can print the error results. So you have the collab sheet, all of you. So you can practice it on your own. Let me know whether there is any question, anything to discuss. Any errors you are facing?
No, ma'am.
Okay, then I'll stop sharing my screen and stop the recording here.